Hey, what's up everyone and welcome to Daily Code Buffer. In this video, we are going to understand about the Resilience4j and the different modules available in Resilience4j. And before that, we need to understand why we have to use the Resilience4j. Now, if you have seen my complete microservice with Spring Boot tutorial, in that we have used the historic dependency for our circuit breakers. So that particular dependency has been deprecated within the newer versions of Spring Boot. So we'll be replacing that historic dependency with the Resilience4j dependency, and we are going to understand the different modules out of it. So without any further ado, let's get started. So now let's understand why we need the Resilience4j dependency while creating our microservices application. So for that, let's understand one of the microservices. So consider this example where we have a client application where client is calling the service A and that service A is calling the another service, that is the service B. So that's a chain of microservices where one service is dependent on the other microservices to fetch data. So it's quite simple, like you have order service and you have a payment service, right? So your order service is dependent on your payment service. Once and only once your payment is completed, your order service will send you the response back like, okay, the particular payment is completed for this particular order or whatever, confirmation or rejection or anything. So one microservice is dependent on the other microservices. Now, when there is a dependency and when there are multiple microservices available within your architecture, there are a lot of things that can go wrong because nothing can be perfect, right? So consider one scenario where your service B is down or your service B is very slow to respond back. So this is one of the scenario that you are facing, and that's a genuine scenario. This can happen. This can happen to service A as well when another service is calling it or a particular that service is also not responding. But when we are working with microservices, this type of scenarios we have to handle it. So when a service A is calling the service B and that service B is down or it's not responding within a particular time interval that has been defined, then what service A can do is it can retry multiple times to fetch data. Okay, it's failing. Okay, let me retry again. If it's failing, let me retry again. You can define some of the retry mechanism to retry the service and to fetch data. The other thing you can do is to implement a circuit breaker type of mechanism where you will define a circuit breaker, and based on the circuit that has been designed and based on the state of the circuit, the request will be processed. And if the service is down, you can also define the fallback method as well. Like if the service is down, use this particular fallback method or fallback API to send the data back as well. And you can also define the rate limiter. So that also we are going to understand within this particular microservice architecture using the Resilience4j, how to implement it. So this is just a basic idea why we are going to implement the Resilience4j in our microservices and what are the benefits we are going to get it. Now Resilience4j comes with a different modules available. You can see that there's a circuit breaker module, retry module, rate limiter module, bulkhead, time limiter, cache. In this particular video, we are going to only focus on the circuit breaker, retry and rate limiter modules because these are widely used. Bulkhead module is also used, but if you want, I can create a dedicated video on the bulkhead. Let me know in the comment section below if you want it. But let's focus on the circuit breaker, retry and rate limiter. So let's understand the circuit breaker first. So circuit breaker is just a simple thing that you have a circuit, that circuit is in the closed loop, and when the circuit is in the closed loop, everything is closed, the circuit is working completely fine. Everything will flow correctly. It's just like your electrical circuit. When circuit is closed, electricity will pass through it. So there are different states available in your circuit breaker, that is closed, open and half open. Now based on the states of the circuit breaker, few of the requests will be allowed and few of the requests won't be allowed. So let's understand that. When the circuit breaker is closed, all the requests will be allowed through the system. So your circuit breaker has to be closed when your request has to be passed. Now if you're facing any difficulty understanding this, don't worry. When we go through the example, you will get a complete idea what the circuit is. But let's understand that when the circuit is closed, all your requests will be passed. So sometimes what happens is your service B is down. So from your service A, you are not able to call the service B. So those particular requests are failing. Now what you can do is you can define the threshold to identify how many requests are failing. Okay, suppose you have defined the window of 10 requests and you have defined the threshold as 50%. So if 50 or more than 50% of requests are failing within that last 10 requests, then that circuit will be changed its status from closed to open. That simple thing. Based on the window that you have provided, sliding window, and the threshold, like how many percentage we should be allowing. So if 50% of more requests are failing, if you have defined 50%, then that particular status will change from closed to open. And when circuit is open, no request will be allowed. And you can define a wait duration for your circuit breaker to be in the open state. So if you define that 5 seconds, then for 5 seconds that circuit breaker will be in the open state and it will change to half open. So if it's closed, everything is fine, and if requests are failing based on the threshold that you have provided, it will change the value to the open, and it will be in the open state for the duration that we have provided, suppose 5 seconds, 10 seconds, whatever. So for that time interval, the status will be in the open state, and after that it will change to half open. So half open is nothing but half of the circuit is open and half of the circuit is closed. So few of the requests will pass to the circuit breaker just to check that my service which are down is up or not. Okay, so once it comes into half open state, again you can define the threshold, how many requests should be allowed within the half open state. So suppose you have defined that 3 requests are allowed in the half open state. Okay, and for that 3 requests, what is the threshold that you have provided? Your threshold is 50%, still you have given the 50%. So from that 3 requests, if 50% or more are still failing, then again it will go back to the open state, and again it will wait for the duration that you have provided, and it will again come back to the half open state. So this cycle will continue until your 3 requests that you have defined for the half open states are successfully completed. If those requests are successfully completed, then that particular half open state will again change to closed, and once it is closed, all the requests will be passed through the circuit breaker. So this is a general idea about the circuit breaker, and this is how the Resilience4j's internal implementation works. So to use the circuit breaker, we'll just add the dependency of Resilience4j, and we will add the configuration in our YAML file. Now there are some of the extra cases as well, like if you have a business exceptions, right? So such type of exceptions occur, that particular exception should not be considered as a failure, right? Because that's a business exception that is supposed to be happen. So all those type of exception you can define in the circuit breaker. So circuit breaker will not treat those as an errors or failures. So those particular will be treated as a success one. But if there are genuine errors, those will be treated as the failures. So that type of configuration also we can do with Resilience4j for our circuit breakers. The next one is the retry mechanism. So retry is simple thing. You just define that how many retries you should do when there is a failure in your service. So suppose you have defined that you need 3 retries when there is a failure. So it will try to retry 3 times, and if you have defined any fallback method, that particular fallback method will be called, or if you have not, then whatever the exception is, exception will be thrown back. And within that 3 retries, if the application is up, then well and good. And you can also define what is the time duration that it should wait for a retry mechanism to kick in. And the next is the rate limiter. Rate limiter is nothing but to identify or to have a check in your system that how many requests should be allowed within a time duration. So suppose your application can handle only 1000 requests per second, then you can define that for this particular URLs there is a rate limiter and you can only hit 1000 times per second. You can define what is the number of times you want to hit and what is the time duration. So that configuration we can do. So we'll see everything in the implementation part. So we'll create 2 services, service A and service B. Service A will be calling the service B to get some data, and we'll be calling from the browser as a client. Okay, we'll be treating our browser as a client. We are not creating any UI application. So let's understand the circuit breaker, retry and rate limiter mechanism using the Resilience4j. So let's create the project for it. So what I'll do, I'll just go to the Spring initializer. I'll just open start.spring.io and let me create 2 projects. Okay, service A and service B. So let me just create Maven project, language is Java, group as com.daily code buffer. Artifact I'll just say service A. Okay, packaging is jar, Java is 11. I'll add the dependency as web dependency, and I'll add the Resilience4j dependency. Okay, that's it. Let's generate this project and let's create one more project, that is service B, and in this service B I'll just add the Spring Web dependency, and let's generate this project as well. And let me open both of this project in IntelliJ IDEA. I'll open the IntelliJ IDEA. I'll open the project. In the documents, Java workspace, Resilience4j. I'll open the service A. And I'll also add the service B dependency. So these are our 2 projects, service A and service B. Let's go to src folder, main resources, application.properties, and let me just rename to application.yaml file. Same way I'll do for the service B as well. I'll go to main resources and I'll change to YAML, application.yaml. Okay, so now I have 2 YAML files instead of properties. It's easier to work with the YAML file. Now in your service A, let me just create one package. I'll just define this as a controller, and in this controller package I'll just define Java class and I'll just say service A controller, and I'll annotate with @rest controller. Similarly, I'll go to the service B Java, and here I'll just create the controller package, and within this controller I'll create one more class, that is service B controller. Guys, sorry for the background noise, there is a construction going on, and I'll just annotate with REST controller. So here you can see that I have two REST controllers. One is service A controller and the another is service B controller. Now, and I have two applications. So let me just define two different ports for my two different applications. So I'll just go to service A application.yaml file, and I'll just define server.port as 8080, and for service B I'll just define as server.port as 8081. Simple, okay? Now first let's implement the circuit breaker. So in the service A controller, let me just define one method, and here what I'll do, let me just define the request mapping as well. /a. Okay, so when I call localhost colon 8080/a, my service A controller will be called. The same way I'll define for service B as well as /b. So here I'll just define one method, public string service A. Okay, and this is get mapping. Now what I'll do over here is I want to call the service B from the service A because I want to get the data from the service B also. Okay, I'm just showing this simple example for you to understand how the circuit breaker, retry and rate limiter works, but this is the same that you will be implementing in a project as well. So now here we want to call the service B, that is the another service, that's the another HTTP call. So we'll be using the REST template. You can also use the REST template, web client or Fein client, anything. Okay, I'll be using the simple REST template over here. So we need to create the bean of REST template and we have to auto wire the same. So let me create the bean. I'll just go to the main application class and I'll just define public REST template and return new REST template. Okay, and this will be defined as a bean. So my bean is ready. Now I can use this REST template bean in my controller. So let me go to the controller and let me just define private REST template, and this will be auto wired. So you just injected the bean. Now we can use this REST template to fetch the data. So for that we need to define the base URL as well. So to define the base URL over here, you have to implement the REST API as well in the service B. So if you go to the service B controller, here you need to define one of the service so that you can call from the service A. Okay, so I can define over here as request mapping and I'll just define as /b. Okay, so when you call /b with port 8081, this particular service will be called. And let's define one method. I'll just define public string service B, and this is get mapping, and this will return service B is called from service A. I'm just passing one string over here. Okay, service B is called from the service A. And to call this particular service B, what you have to do is you have to have the URL, that is the localhost colon 8081, because that's the port number for my service B, and /b is the URL. So let me go to the service A controller and here I'll define private static final string. Okay, and I'll just define base URL equals to URL http localhost colon 8081 / okay. So we have just defined the base URL. This base URL we can use to fetch the data from the service B. So what I'll do over here, I can just do return REST template dot get for object, and here I'll define base URL plus /b, and the object type is string.class. Simple thing. Now let me just extract this to the variable. Let me refactor it to the variable. Okay, so I just define the string URL that is equal to base URL plus /b. Okay, slash I have already added, so let me just remove that. So here you can see that I have not done anything special over here. I am just calling one of the service that is from the service B from the service A. So now let's run this and check if it is working. Okay, till this point. Okay, second service is also starting. So here you can see that both the services are started. Now let me go to the browser. Okay, and if I call localhost colon 8080/A, and here you can see that this /A has called the /B, that is the backend service. Okay, here /A, you can see that the /A is defined get mapping over here. So this service A has been called, and that has called the service B over here, and we are getting the data from the service B. That is the service B is called from the service A. Now what I'll do is I will just get down this service B. Okay, you can see that service B is down. Now if I refresh it, you can see that I'm getting the error over here because I'm not able to call the service B from my service A. So let's implement the circuit breaker over here. So whenever this type of scenario happen, we can call the fallback method as well. Okay, so what we can do, simply whatever the method it is, okay, service A, what we'll do, I'll just define this as @circuit breaker from the Resilience4j. Okay, now we need to give the name to the circuit breaker as well. So let's give the name. So here let me just give private static final string, and I'll just give service_A equals to service A, and here I'll just define circuit breaker's name equals to service A. Okay, now we need to add the configuration for the circuit breaker as well, and we can add the configuration for the fallback method as well. Before that, we need to add the couple of more dependencies as well. So let's add the dependency. I'll go to the service A and pom.xml file of it. So the two dependencies I wanted to add is the AOP dependency and the actuator dependency. So in this dependencies, I'm just adding these two dependency. One is the Spring Boot starter actuator, and the other one is the Spring Boot starter AOP. Okay, actuator is for our health endpoint, just to identify what is the health of our application. So Resilience4j can understand what is the health, and accordingly it can perform the circuit breaker, rate limiter, and all those stuffs. Okay, so these two dependencies were needed, so just added it. So now we need to add the actual configuration for our circuit breaker in our application.yaml file. Okay, and this particular configuration we will be adding for a particular circuit breaker, that is the service A circuit breaker. So I'll add the configuration directly, and I will explain you the configuration because I don't want to mess up with the YAML file for now. Okay, so the first thing I'm doing is enabling the management endpoints for our actuator. So whatever the actuator that I have defined, I am enabling the endpoints for that. So you can see that management health circuit breaker endpoint I have enabled, and the endpoints web exposure include health as well. So I have added the health details as well in that. Okay, and I'm also adding that for endpoint health, always show the details. Okay, so this is the standard configuration for your actuator. Okay, so this is your actuator configuration. Now let's add the configuration for the circuit breaker Resilience4j. So now here you can see that this is the configuration for your Resilience4j circuit breaker. So this is the standard that you have to add, and then you have to add the instances. So what is the instance? So you can see that my instance is service A. So that whatever the name you define as your circuit breaker, the same thing you have to add in your application.yaml file. So this is your service A. Okay, and within the service A, you need to add some of the configuration how your circuit breaker should behave. So I'll just define that register health indicator, whatever the health indicator that we have defined, we have added over here. So in my health indicator, we will be able to see what's the status of my circuit breaker. So I'll just show you how to see that as well, and you can see that how many events we should be consuming. So that's a 10 events that I have defined over here, and you can see that failure rate threshold that I have defined, that is the 50%. So 50% or more is the threshold. So whenever it hits 50%, my circuit breaker will change its status. So whatever I have defined in the presentation. Okay, so that I have defined over here, and I have defined the minimum number of calls. So how many minimum number of calls it should check for. So I just defined that minimum number of calls it should check was 5. And I would also define that automatic transition from open to half open enabled. So I have enabled this, so that's why it will automatically transfer from open to half open. Okay, this can be done manually as well from the code. So wait duration in open state, so how many seconds your state should be in the open state, after that only it will change to half open based on the above automatically. Permit number of calls in half open state, so I have defined that 3 calls should be allowed in the half open state just to check my other applications are up or not. And I've just defined the sliding window count. So there are 2 different ways to define your sliding window. One is time based and count based. So here I have defined the count based. So we will be having the 10 count for our sliding window. So based on that count, this particular all the operations will be performed. Okay, so this is just a standard configuration. Now if I go to service A controller, okay, and this is my API. Now if this fails, right, if there is any issue in that your service B is down or slow, okay, your circuit breaker will kick in, and if you want you can define your fallback method as well. So let's define the fallback method also. So here I can define public string service A fallback method. The only thing you have to make sure is the return type should be same and it should be injecting the exception. Okay, that's the 2 thing. And suppose this will return, this is a fallback method for service A. So this is the fallback method that you have defined. Now this fallback method you can configure over here. In the circuit breaker annotation, I can define fallback equals to the name of the method. And make sure that you are defining in the same class. Okay, so that's the configuration for your circuit breaker. Now let's restart the application and see what is happening. So let me just stop and rerun. And here you can see that your application is started. Your endpoints are exposed for the actuator as well. So let me just go back to the browser. And if I do localhost 8080/actuator/health, okay, you can see that this was the health endpoint that we have exposed, and here you can see all the information. Here you can see that all the information of the circuit breaker. You can see there is a circuit breaker and the status is up. This is the service A circuit breaker, and these are the details. What are the failure rate? Failure rate threshold is 50%. What are the slow call rate threshold, buffer calls. Okay, current state is closed, and what are the non-permitted calls and failure calls and everything. Now this is my endpoint, and if I refresh it, you can see that this is a fallback method for service A. So there is some issue in the service B. What's the issue in the service B? Service B is down, right? You can see the service B is down. So let me just start the service B. Now you can see that after starting the service B, you can see that you're getting service B is called from the service A. And if I refresh over here, you can see that there are 2 buffered calls. If I refresh multiple times, my buffered call will increase. Okay, and you can see that your failure rate is also decreasing and your state is closed now. Now as we have defined in our application.yaml is our threshold is 50% for the minimum number of calls as 5. And if I stop this application, okay, it should fall back to the fallback method. Okay, and if I do multiple times, suppose 5 times, 1 2 3 4 5, okay, my status should change to open. You can see that now my state is open, and you can see that after 5 seconds it changed to half open. Okay, now in this half open state, it will try to check what are the number of requests that we are passing, right? It will try to check that all those particular requests are completely working fine or not. Currently it is not. So if I still hit 3 times, because we have defined 3 requests, so if I still define 3 requests which are still failing, 1 2 3, this status half open will change to open. You can see that it's open. Now after 5 seconds again it will change to half open. You can see that it's now in half open. Now what I'll do, suppose my service B is up. Okay, so let me just start the service B. Now my circuit should be closed. Currently you can see that it's still in half open. When it will close? When the threshold is more than 50%. Okay, so if I now refresh the application, so I should be getting a complete call from the service B as well. So I should be getting, this is a service call from B from A, service B call. You can see that this is a service B call. Service B is called from service A, and you can see it's still half open. Again refreshed, still half open. This is the third time. Again refresh, and now you can see that circuit is closed. So all the requests, you can see that it was more than the threshold and it was success. So that's why it changed to the closed status. So yeah, now the circuit is completely closed. So if you see this particular example, right, you can understand that how the closed, open and half open is working. So it's everything based on the threshold that you have defined and the number of requests that you want to allow and the waiting time. So I've just defined the very long waiting time just for you to understand, but ideally when you are doing in the production, the waiting time will be very low in the nanoseconds and microseconds. So keep that in mind, and I'll add the link in the description below for the actual documentation also. So whatever that is defined, you can actually use those, because that's the standard configuration you can directly use and it will work smoothly. This is all about the circuit breaker, how you can implement the circuit breaker, what is the fallback method. You can see that we defined the fallback method and it was going to the fallback method as well. Now if you have implemented the circuit breaker, there is a chance that you can implement the retry mechanism as well. Suppose you are trying to call one of the service like service B, right, and you are not getting the response, then you can try a couple of times. You can define 3 times. Okay, I'm trying 3 times and still I'm not getting the response, then you can fall back to the circuit breaker. That's a standard way to do, right? So what I'll do, I'll just show you how to implement the retry mechanism as well. We'll just comment out the circuit breaker for now just to understand the retry mechanism. Okay, so let me just go to the service A controller and let me just comment out circuit breaker and let's implement the retry mechanism. So for retry, we will just define the retry annotation and the name we have to define. What is the instance name? The same we will define as service A. Okay, and here also we can define the fallback methods. Okay, and if we don't define the fallback method, that is also fine. So let me keep it the same way. Now just to understand how many retry it's happening, let me just add the loggers as well. I'll just print over here retry method called, and I'll just define integer count equals to 1 count plus plus, and I also define at what time. Okay, at plus new date. Simple thing, right? Now for this particular retry as well, we need to add the configuration for that. So let me add the configuration for that as well in the application.yaml file. Here circuit breaker you have defined, right? And after that you need to define for the retry. So this is the configuration for the retry. Retry instances same service A, and you have defined the registered health indicators, and maximum retry attempts you have defined as 5, and what is the wait duration? That is the 10 seconds. So for every retry there will be a 10-second gap and the next retry will start if the service B is down. Simple as it is. Okay, so this is a very simple configuration. Now what I'll do, I will just go to the service A controller. Everything should be same as it is. Let me just restart the application. My service A is also started, service B is also started. Let me go back and you can see that it is completely fine. Okay, and you can see that I'm getting that retry method called 1 time. All good. Now let me just restart it because I have just defined count over here. Okay, let me just make this count outside. Okay, and let me just start. Now what I'll do, to mimic that service B is down, I will just stop this server for service B. Okay, only service A is started. So what it will do is, it won't get the request from here. There will be a error over here, so it will try to retry it. Okay, so let's check that. So here you can see that it's trying to retry, and if you check the logs as well, you can see that it retried first time, second time, third time, and meanwhile if we start the application, You can see that we got the response, that is the service B is called from service A and the processing is stopped. So this way you can see that the retry mechanism will work and it will try to retry at the point that you have defined, like how many times we want to retry at what particular time interval. So you can see that everything is handled by the Resilience4j. You just define the annotation and you just define that what is the interval and what is the time that you want to retry. Everything is handled by the Resilience4j. You don't have to worry about anything. It's very easy implementation, and this type of implementation you should do in your microservices to make it work cohesively, because any microservice can have issue at any point of time. Okay, we cannot predict anything. So now the next one is the rate limiter. How to add the rate limiter for any of the URL. So now let's implement that. Let me just comment this out and let's implement the rate limiter. So rate limiter is the annotation, and I can define the name as still service A. That's it, right? Now we need to add the configuration in the application.yaml file as well. So let's add the configuration for that. So here is the configuration. After retry, this is the rate limiter. So for rate limiter also instances, I am defining the service A instance. Now as I've created the one instance, now if you have multiple instances, you can define the default configuration as well. Okay, that will also work. I will add the link in the description below for you to check how to add the default configuration, and if you want to change configuration for any particular instance type, then also you can change accordingly. Okay, it's very easy. Okay, here you can see that limit for period, that is 10, and limit refresh period is 10 seconds and timeout duration is 3 seconds. So here you can see that for 10-second interval, 10 requests are allowed. Okay, 10 for the period. So I have defined 10 seconds over here now, just to make sure that we are able to see what is happening, but ideally you will be giving those times in microseconds or nanoseconds. So now let's restart it. Now let me just open the developer tools over here, and in the network tab it shows the time interval. Okay, so what should happen over here is within the 10-second interval only 10 requests are allowed. After that, if there is another request, it will wait for 3 seconds and your request will be processed. As simple as it is. Okay, so you are defining a time interval like for 10 seconds, 10 requests. After that, if there is more request, wait for 3 seconds and then it will be processed. So if I refresh, and in the below you will be able to see what time it took to process that request. The last request after the 10th request, it should take 3 seconds plus whatever the time it takes to complete the request. So let's refresh. You can see that to 10 milliseconds, 6, 7, 8, 9. So here you can see that it waited, right? It's still waiting to process it. So here you can see that you are getting that it took more time to complete the request. Now here you are seeing the error over here. That's because that we have not defined any fallback method if this occurs. But if you have defined the fallback method, that particular fallback method will be called and those particular data will be displayed. Okay, you can see that it took more than 3 seconds to complete this request. So this way we can add the rate limiter for our REST APIs as well in our microservices. This is just a standard that we have implemented, but we can do a lot more. If there is some standard exceptions that are to be bypassed, that also we can implement. Like these are some business exceptions. These business exceptions should not be considered while retry mechanism or circuit breaker that we can add. We can add the custom delegates or custom suppliers to handle all the retry mechanism and rate limiter and everything. All the things we can do from this particular configuration, from the YAML file also, and from the Java configuration also. So if I take you to the Resilience4j page, so here you can see that everything is given. You can see this is how you can implement using the Java code as well. We have implemented using the YAML configuration. Okay, standard configuration in the Spring Boot. But if you want to use from the Java config, you can do the same. And you can see all the modules are given: circuit breaker, bulkhead, rate limiter, retry, time limiter, cache. All these things you can implement. We have just gone through circuit breaker, rate limiter and retry for now in this video, because those are mostly used. Bulkhead is also mostly used, but if you want, I can create a dedicated video on the bulkhead. And you can see all the examples are also given. If you're using RX Java, if you're using Spring Boot, Spring Reactor, Micronaut, whatever you are using, all the examples are given, and I'll add this link in the description below for you to check out. And also I'll add the GitHub link for this particular tutorial, whatever we did in this video, plus whatever is mentioned for this particular documentation also. That example also I will add, so you can refer the configurations from there as well. So that's all in this Resilience4j. Now you can implement the same thing in the microservice as well. I have created a dedicated video for the microservice. Try to implement the same thing, Resilience4j, in that particular tutorial as well. And if you have any doubts, then do let me know. And if you want, you can also learn to deploy that particular microservice in the Kubernetes cluster and the Google Cloud platform as well. So those videos are here as well.